Another question, question number 8. We have to express it in the form r cos theta minus alpha. Very easy. So let's get started. First, we're going to be finding the value of r. So if we just compare it with a cos theta plus b sin theta, it gives us the value of a to be 2 and b to be 8. If we have to find out r, so we know that r is square root of a squared plus b squared. That gives us 4 plus 64, 68. So r is 68. To express it in the form, we need two values, r and alpha. Let's find out alpha. So for alpha, if we expand this, we have r cos theta minus alpha. If we expand that, it will give us r cos theta cos alpha plus r sin theta sin alpha. Okay, and if we check our equation, so we have cos theta over there, cos theta here. So can we say that if we compare both of them, can we say that r cos alpha is equal to 2? Similarly, r sin alpha is 8. Overall, the quick short trick is every time you have done it in your learning time, tan alpha is always b over a. So instead of comparing, expanding, writing, you can directly write tan alpha is b over a. So that is tan alpha is 8 over 2, that gives you 4. So alpha is tan inverse 4. Or because we were following this method, out of these two we can find out, we can follow any one. So it would be giving us cos alpha, that is equal to 2 over r is square root 68. If you solve it for alpha, that would be cos inverse 2 over root 68. Okay, let's find out. Okay, cos inverse 2 over, it gives us 3 decimal places, 1.326 3 dB. Correct? So this is what the A part is. Let's quickly match it first. So we have, they did tan alpha thing, though they have written both the values first. Never mind, 1.326. I think we've got the same. Yeah, okay. Now for B part, what we have to do in B part? The first 3 terms of an arithmetic sequence are this. These are the first 3 terms. And given that S9 represents the sum of the first 9 terms, that obviously, okay, we have to find exact maximum value of S9. Okay, S9, sum of 9 terms. So S9 would be, what the formula is, 9 halves 2a plus n minus 1 into d. Now let's write down the thing here, cos. We have cos x plus sin x. I'll be keeping it, sorry, not plus, but cos x plus sin x, cos x plus 2 sin x. These are the first 3 terms given to us. So overall, cos x is normal, like common, cos x, and sin x is started from here. So our A would be, let's try finding out A. So A is cos x, and D, if you subtract these two, the difference would be sin x. Hope that makes sense. If you subtract these two, you're going to be getting sin x, and A, the first term is A. Let's substitute all these values there. So 9 halves, this is 9 halves, and 2 cos x plus 8 sin x. This is what the value of S9 we've got. Okay, what we need to do, find the exact maximum value of S9. So what we can do over here, we can find out the value of R. So as you can see, A and B is the same. So R, you're going to be getting square root of 68 only. That can be simplified as 2 root 17. So if you substitute here, you're going to be getting S9 to be 9 halves times 2 root 17. That gives you 9 root 17. And that is your answer. Now BII. For BII, it says reduce the smallest possible value of x at which this maximum value of S9. Okay, so we have to find out smallest possible value of x for which this is maxima. So shall we use some calculus thing over here, because it is saying maxima. So at maxima, ds over dx will be 0. So let's differentiate this thing. It would be giving us, let's keep 9 halves there. Okay, it would be giving us minus 2 sine x plus 8 cos x equals 0. So we can say 2 sine x equals 8 cos x. So from here we can say tan x is 4. So x will be tan inverse 4. Let's find it out. Tan inverse 4. It's giving us 1.3256 again. So like if you want to take 2 decimal places, 3 decimal places, if you take 3 decimal places, it would be 1.326. Oh, sorry, it was 8. Okay, what I'm trying to say, what I was missing, yeah, this is radians, huh? Remember, not to be adding in degrees, but radians. Let's quickly check the answer. So we have first, I think we've marked, and the second is 9 root 17 and 1.33. Okay, they are taking 3 decimal places. So yeah, we can also write 3 decimal places here. So it would be 1.33. Correct? Okay, hope that makes sense. Bye bye. Take care.